Hello everyone. Now I'm going to present to you the, the next pattern. Its name is Decorator Pattern, proposed by the book Head First Design Patterns by Eric and Elizabeth Freeman. I have a friend who works with me in this pattern, and so what I will present to you in this talk. So first I will introduce you to the problem of the coffee shop and how they originally implement their system. It has some issue, and and next I will show you how the decorator pattern help solve their issue and extends their business even more. Lastly, I will show you the code and I'll show you the code in C++ that you can refer to. And finally, I will wrap up with the big advantage of this particular pattern. Okay, here's the problem. A coffee shop in America called Starbucks is trying to make a system that can sell their beverages to customers with different types. But it's not the coffee itself, it's also the condiments that customers want to order additionally to their drinks. It could be matcha, it could be additional milk, and so on. So, here's what this coffee shop implements in the beginning. So, they create every, every subclass, all subclasses with type with every type of coffee combined their with every condiment. So it creates a disaster. So how can you maintain this? I mean, if we have a new type of coffee, if we have a new condiment, then we have to calculate the cost, and then we have to put put them in. It is very inconvenient. Okay, so how the decorator pattern will help solve this? Its principle says that classes should be open for extension, but closed for modification. So the, the extension here is the coffee, is the types, the combos of coffee, any combos of coffee with different types of condiment. We should be able to make any type while letting the cost be calculated by itself. That's that's what it means. So this is an overview of how we do this. So when we order the coffee, the cost will be this. But when we add the new condiment, the cost will be calculated. And when we add another new condiment, the cost will be recalculated again by itself. We don't have to touch it, we don't have to create new instances. Okay, so now I will show you how to implement this pattern in C++. Um, sorry. Okay, so we need to include the necessary libraries. Now we will create a big class called beverage. It will have a description. So the default constructor, I set the description to be unknown beverage. And when we set it, it will come with a description. And since there could be multiple instances, subclasses of coffee, so I will use the virtual operator here. And since I know there could be pointers and new, so I will set the destructor. destructor. Next, I will create a big condiment classes with all types of condiment. It will be the decorator. Okay, now we will create some instances of my beverage. House blend and dark roast. Each type of coffee will have its own particular description and cost. See, each coffee will have its own description and cost. So this is the end. And now I will create some types of condiment with with its cost. So we need the class beverage here. So this is what the miracle happens. This description will be enhanced. It not only covers the description of the beverage, like coffee, many types of coffee, but it will also have the description of the condiment itself, and the cost will be modified by itself as well, including the cost of it and the beverage cost. So we will do similarly with other types of condiment for matcha, for soy, with their cost plus the beverage cost, and so on. Okay, so the idea is that for every time we we call we call the condiment, it will add its description and the cost to those of the beverage itself. So here's the coffee. Hey, the owner, I would like the espresso with milk and mocha. Please, please, please give it to me. Okay, first I will create the new beverage class. It will be espresso. And now I want to order the milk and mocha. So I will modify my beverage to be with the milk and the matcha. And let's see the description and the cost. So originally the cost is only $1.99. Let's see. Oh, sorry. Let me run it again. Okay, so now the description is much longer. It is not only espresso, but it has milk and matcha. Since we add the new thing, we extend it, and the cost will be recalculated as well. Is the second example. So a dark roast with matcha and soy. First we will initialize the beverage, and then we add more condiments, and now we get an updated description and cost with very little altering in our code. Okay, so that's how we implement the decorator pattern in C++. So what are the big advantages of this? So the decorator pattern places this coffee shop with enhanced resilience and extensibility. They can add any types of condiments, and they just put in the cost, and then when the customer order any coffee with it, it will be recalculated. The description as well as the cost will be updated with very least altering in the system. Okay, this is a big advantage of the decorator pattern. We can add any new types of coffee or sizes and let the system modify by itself. We should be flexible to change, to add new things, but the modification should be done by the system. Okay, this is the end of my presentation. Thank you so much for listening.